Foxtrot in this meeting.
Hello, welcome everyone. I think we would give it 2-3 more minutes and then we may start, just in case there are people who join late.
Welcome, everybody. I think, if possible, anyone can introduce himself or herself in the chat while we are waiting for a few colleagues to join.
Andre, can you share the presentation already?
Yeah.
Andre, you're going to put it into presentation mode? Thank you.
Let me know if you are seeing the comment or no.
I can see your full screen presentation and I can see the chat.
Are you seeing the comment?
Your notes?
It's okay, Andre.
The notes, I mean.
No, I can't.
Okay, good.
Hello, okay, I think we can start. So welcome everyone to this webinar series, which we are going to start today, which we have themed diving into wells or boreholes, whichever we would like to call it. It's a webinar series that has been produced by the Watson team of OCBA, and it's going to cover a range of topics. For today, we are going to be talking a little bit on basics of well constructions. And to continue the series, we are going to talk a little bit about pumping tests, which is going to be done tomorrow. And probably in October, we are working on providing another webinar in October on well borehole rehabilitations. And eventually, if there is going to be interest, if there is going to be request, perhaps another topic that could be brought up through our discussions we are going to be having today and tomorrow. To present this presentation, we are going to do it by Andre and myself, Andre Kamano and myself. We are both MSTs with OCBA. And Andre, I give you the floor to dive into the subject matter.
Okay, thank you, Olivier. Welcome to our colleagues that are around. So today we'll be diving into well, especially we'll be talking about well construction. So this first session on basic on well construction, we'll be having as a content. First, we'll be seeing the planning. In the planning phase, we will talk about why and when to drill a borehole. Secondly, we will be talking about well components, where we talk about the geophysics, the designing of the borehole, the supervision, and the flushing. At the third moment, we will be talking about the common mistakes that occur when we are doing the borehole in the field. And at the end of the presentation, we will share some resources and the documentations that we have available in our Logly and that you can also access. So quickly, we will be having some key learnings that we hope that everyone will understand and then take away after this session. First of all, we'll be talking about some considerations. Main naming consideration is what we need to ensure before engaging in drilling a borehole. Secondly, we'll be talking about the components to understand all the steps that we'll be going through to realize or maybe to build our boreholes. And at the end, we'll be talking about the monitoring session, how to supervise, and what are the data to collect. We then start by the planning. When planning a borehole, compulsively, we may need to have the need assessment. The need assessment, which goes with talking about the use we will be having for our borehole. We will be having some idea of the peak flow. When is the need for that the water that we are willing to produce? And then at the third point, we have to extend our thoughts on the location. Where are we going to locate it normally? From that, we will talk about what the water quality and then the safety of this water. How is it? Where is actually the safe point to have it? And later on, we will talk about the technical requirements. So these are the basic thoughts that normally we need to have when planning to have a borehole. Upon those points, we may straightly look at the legal and community engagement considerations, which mainly are based on beneficiaries, but also authorities. Talking about beneficiaries means that we need to consider the participation of community, which is very essential in terms of managing the system that we are intend to build, but also to see how the authorities can manage it. On the other hand, we look at also on the questions, if actually the authorities are not able to manage it after we have built it, what will be then the outcome or maybe the alternative of handling it to the community so the system can be much more sustainable. So these are the first considerations that we may compulsively need to look at when trying to plan a borehole. After this one, then we now switch straightly to the point, which will help us to clarify more ideas about what we are planning to do. We then talk about what is the type of borehole that you may need, because we have gathered already the informations. Then we will say, okay, are we going now to have a borehole, but which type? So meaning we jump directly to the different type of wells and boreholes that we may know. For this webinar, we have choose two criteria that we may be talking about. The first criteria that we choose to talk about is the depth and the type of aquifer. So we have choose the shallow open well and boreholes, which you can see here the picture on top at the right corner. And talking then about the shallow boreholes, we name them as the borehole which goes up to 40 and 50 meter deep, not more than that. And then mostly they are typed in unconfined aquifer. And then we realize also that sometimes they are most vulnerable to the pollution because of the depth. The second type here in the first criteria is the deep borehole, which go beyond the 50 meter up to 300 or sometime above. These are the type of borehole that goes into the aquifer, and then they are more reliable, and sometimes they are described as having a better quality of water. The second point or criteria that we have choose for our webinar is the criteria based on construction methods. For that one, we talk about then the hand-dig wells, we talk about the drilled boreholes, the jetted borehole, and the driving borehole. The hand-dug well are mostly manually excavated. Sometimes they are lined, or they are sometimes lined with concrete or bricks even. Second part, we will talk about the drilled borehole, which are most common in our countries and in most of the regions. These are created by using a rotary, a percussion, or down the hole drilling. So they are the most common that we find. And the third point, the third group that we find here is actually the jetted borehole, which are dig by using the high pressure water to create a hole in the suitable for loose soil, in the loose soil, sorry. And the last one that we have named are the drawing borehole. The drawing borehole are those that are made by having a narrow pipe hammered into a stuffed ground. Mostly it is done in the drawing in the sandy area. Well, now we have decided that we need to build our borehole. We know what type of borehole we would like to do. Directly, the question will be, where actually are we going to drill it? Where are we going to drill it? We conduct us of making some research that we call the geophysical survey. The geophysical survey will help us to choose or to select the site where we are going actually to have our borehole or maybe our well. Knowing that the geophysical survey is done into two phases. The first phase is actually the summary of available informations that are done online. And also, we can make it by consulting the geological map, by consulting also the country's hydrological database. Then, after we have consulted all those informations, they will then enable us to choose the probable sites that we may need or that we may select. There can be 2 or 3 of them, the probable that we may select for our borehole. The second phase then will be conducted on the ground or in the fields. In the field then, we will be making the exploratory phase. The exploratory phase then is carried out in the field, as I said, and it consists of identifying the site with the best aquifer potential from among those selected in the phase 1. So it usually involves the exploration that we use some methods. The methods that are commonly used are gravimetric, electrical, and they can be also electromagnetic and seismic. And then after we have choose it helps us to identify the best sites among those that we identified previously. You have to notice that the geophysics is done actually normally by a credited hydrogeologist, so that we can have the best result or maybe the best analysis. This second phase of the geophysical survey is closed by a writing report, which will give us all the details and all the information that we may need to develop our borehole. Talking to that, then we are going now to start the designing, like the technical phase of doing our borehole. And then we jump into the designing of the borehole. Talking then about the designing of the borehole, we start by trying to estimate the depth. And this will be based on the water table, the aquifer locations, the geology, but also the water use. As a reminding, all those points have been already identified or maybe mentioned in the geophysical survey and clarifies the question that we may have around the water table, around the aquifer location, and also the geology. So what is then the basics that we may need to know when defining the expected depth? We may be focusing on the hydrogeological survey, as I mentioned it earlier, but also it is possible that we use the test drilling. So the test drilling is actually the drill consists of drill a pilot borehole while monitoring. Water request and inflow indicates then the aquifer that we have identified, or maybe that will be preferable for our borehole. The third point here that we can use to estimate our the depth of our borehole is the local knowledge. Talking about the local knowledge, I mean here the consultation or maybe the visit on neighbors to see the borehole that they have, to ask them then about the questions, the seasonal variation of the water level, but also we talk about the depth and the gel of their borehole. This will give us the idea about the one that we would like to drill in the community, and it will give us also some idea of how deep we can go. But the limitation of this third point goes always a bit higher, because the information that we may collect from the neighbors may not be very accurate. Then after we have designed the borehole depth, we may be thinking about then the diameter of our borehole. This is the second point that we may look at when designing our borehole. Then when we are trying to design the diameter of our borehole, we may compulsively need to think about the expected safe gel. We'll talk about the expected gel. So it means that if we are required to make a high flow borehole, then we may need a larger pump to do it. Talking about the larger pump compulsively mean to have a bigger diameter of the borehole, which will allow then the pump to get in, because the pump will be much more bigger. Mostly what we refer is that the borehole, if actually we need a bigger diameter of the pump to pump the water outside, then we need also the borehole to be bigger, the diameter to be bigger. Mostly we propose that 1.5 to 2 inch larger than the expected pump. So the diameter of the borehole should be 1.5 or 2 inch larger than the expected pump that will be used. Later on, we will be also focused on the depth of the borehole. Talking about the depth of the borehole that we determined previously means that deeper is our borehole, bigger should be our pump to be able to pump the water inside, because the deeper is the borehole, the higher the total dynamic head should be. So the distance then taking the water inside the pump, the borehole up to the end service should be considered also. The third point here is the geological conditions. In some conditions, the unstable geological formations need to have a bigger diameter of the borehole, so we can try to have the thicker casing, or sometimes to condition it with the supports like the centralizer, to make that the borehole should not collapse. Okay. The other point that we may consider in dimensioning the diameter of our borehole is actually the drilling method. When we have a borehole and then we define already how the diameter should be done, we need also to consider the type of drilling method. There are drilling methods that have different diameters. Maybe we talk about the different method later on and the possibilities of making it. The last point here to mention is the multi-use need. Okay, so if the borehole is to be used for monitoring or installing multiple sensors, so we need to make a bigger diameter, so all the parameters or maybe all the machines or other things that we may put inside for the monitoring of the water should be incorporated and can then be inserted inside. We have also other considerations that we may need to look at when dimensioning the diameter of our borehole. It may be like the regulations in the country. It can also be the cost when making it, like the cost for the casing. We may also think about the size of the casing available in the country, or the pump, the type of the pump that we may be using to make our borehole wet. All those can be in defining the borehole diameter size. And then after we have choose the diameter, we now go to choose actually the drilling method, as we mentioned here. So talking then about the drilling method, I'm going to give you 30 minutes so that each participant may type in the chat the drilling method he has here before. So what are some drilling methods you may think of? Please take the time, 30 seconds, and type them in the chat so we can go. 30 seconds, please. 30 seconds in the chat to type the methods, the drilling methods you may know or you may think about. Okay, great. Thanks to those who have typed in the chat. Then I'm going now to show some drilling methods that we commonly find in the. Then we will be talking about the first drilling method here, which is manual drilling, manual eagle drilling. And then this one is sometimes the rotation by hands, which will allow then the cutting into the soil with blood and the pass to the cut material up to a continuous spray into the spray, or sometimes by the bucket. So we turn with the hand, physical manpowers, to see then how we can make it. And then sometimes it is like the excavation by the material that needs to be moved by human. It is turned around. But this method has both advantages and disadvantages. Okay. In terms of advantage, it is very simple technology to be used, and sometimes it is very cheaper. In terms of disadvantages, you will see that it is only used for the very shallow deep well, like not more than 40 or 50, according to the formation of the geology. The second type here that we'll be talking is the percussion drilling, which is also very simple in terms of advantage and is sometimes low cost operation. But in terms of disadvantage, it is sometimes very slow, and then it is used also for only the shallow depth well. Okay, and the third one is the rotation, which we find mostly in the countries, as we mentioned it. But this is very faster drilling. It doesn't have the limitation of depth, but it needs no temporary casing sometime. In some cases, the disadvantage in this one is very expensive, okay, and it may need a large work space for ridge and the mud pit. So though it is fast, but sometimes it is expensive. And we will be talking then about the rotary down the hole by circulation, or maybe reverse also circulation sometime. So these are also the methods that are very fast, mostly in hard formations, but generally not to use in soft, because when we are having the unstable formations during depth below the water table, it limits actually the hydraulic pressure. Okay, so these are the types of the drilling method that we have identified for this webinar. We may find also others, but in the different applications maybe in the mining or something else. Okay, so when we have choose neither the manual drilling or the rotary drilling or the percussion drilling, we conclude at one thing, the borehole, which is actually having some component that I'm now going to display so you can see. Whatever the method that we have used, we may be finalizing by this component that we have here. The first component that we mentioned here is actually the borehole casing. The borehole casing will serve to prevent the collapse of actually the borehole that we are drilling. Okay, it also serves as the block for contaminants. Most of the time, we use the PVC pipes, or sometimes we use the steel and the stainless steel. The only condition that we may need in choosing those things is that it has to be corrosion resistance, and it has to be very well sized when we are choosing it. The second component that we'll be talking here is the screen. The screen will help us to filter out some sand, but also to allow the water to get into the casing. The third one that we may talk about is actually the gravel pack. The gravel pack will stabilize the borehole. It will also enhance the filtration. This is actually made by washed gravel. As you may hear it, gravel pack is actually the washed gravel, and sometimes the sand that is having larger diameter than the screen that have been slot. It prevents also the thin particle from clogging the screen. The other component here is the cement or the bentonite. The cement or the bentonite will here help us in terms of blocking the contaminant from the surface of groundwater or maybe other contaminants. Okay, it is normally placed it is placed into at the top of the seal annual space. So as you can see it here, it is placed here at some levels. It can go up to 6 meters, sometimes deeper, so to prevent the infiltration of all the runoff water here, or maybe sometimes the septic tanks water. Okay, the other point that we mentioned is actually the pump. But this one is not during the drilling that we find it. It's after we have finished the development of the borehole, or maybe the drilling, that we put it inside. So it will help us to take out the water. And then you may know that this pump is linked to outside connections here by the power cable, but also by the pipe, which can be PVC or sometimes the galvanized one. Okay, and the power cable here to let our water go a bit up. So when we have already all those things, we may think of our borehole is safe. But how can we make that our borehole is safe or maybe well drilled? Not all the time. We have to talk about the supervision then during drilling. Because when we are drilling it, we are working with two actors. The two actors we are working with are actually the driller and the supervisor. We'll be talking about the rule. The driller, his rule here will be to drill only the borehole according to the specification that have been described by MSF or by the clients. The supervisor here is here to look and to watch the respect of technical specification and also to keep the recordings. This one, in the case of MSF, it can be an MSF staff, or it can be someone that is the representative of MSF if MSF is not able to reach in the area where we are performing the activity. And why should we then have the supervisor in terms of drilling? Because we have realized that according to the Rural Water Supply.net sites, 60% of groundwater sources that are not working in some African countries fail due to the poor and sustainable substandard construction. you will realize that during the construction, if there's no supervision and the driller is not conscious by doing it, he will then try to make it as he wants, and things that make it him very easily to go, and then it will then fail. And we'll be talking about a few tasks to show a bit the importance of supervision drilling borehole. Let me take an example of drilling. During the drilling, what the driller should supposed to do is to position and operate the ridge to collect sample and make the report. This is what he will be doing. While doing that, the supervisor should be around. He will be monitoring the drilling. He will also advise on the depth to stop drilling or to continue, or maybe to log also the borehole, because we will see later on when we be talking about the quality insurance that the supervisor should be around to be mentioning or recording all the information normally to be able to recognize that the borehole is well done or not, or it has respect the prescription that we had into the technical specification at the as set in the beginning. So the supervision can be at several levels. First, we'll be talking about full-time supervision. The full-time supervision is that the supervisor remain with the drilling teams throughout the entire process. Okay, he will now move from the beginning till the end. He will be around, he will be recording everything, he will be advising on each modification that should be. The second level of supervision is the part-time or milestone supervision. This is actually done when you have like a contractor that you have trusted, and then that you know previously the quality that is normally the quality of his work. So the supervisor will be here only for at the critical moment. He will be like the selection of the site, and later on he will come to do the drilling termination, or maybe he will be just here for the mobilization, or maybe the construction of the platform at the end. So only the key moments he will be participating. The other moments that are not so much crucial, he will be away. The third level of supervision is actually the end of contract inspection. This is when actually you have a full trusted contractor. He will perform the work, and at the end, the supervisor will come. This is not like the true supervision, but it's like the final inspection to be sure that everything went well, and then to collect the information about what was done. Okay, then how should we make a proper supervision when we are drilling the borehole? Doing the proper supervision and then to ensure the quality will lead us of filling up some forms when the driller is performing his work. We have a document that we call the borehole drilling log that normally we try to fill up according to the different depths, according to the different level of the ground. We are going to fill it up according to the various changes that happen. When we are filling this one, it helps to determine, okay, we have defined 80-meter depth, approximative depth for our borehole, but arriving at 70, maybe the supervisor may say, okay, we can stop here. We have reached already a level where normally we can stop. We then validate that, or he will say we should continue up to the 18 meters. The other document that normally should be also filled when drilling the borehole is the design log. As we mentioned at the beginning, we need to design the depth, but also the diameter and everything. Then this second document here that you are seeing at the right here will be also filled by the supervisor, who is the representative of MSF, to be watching closely the changes that happen during the drilling. After then he has filled the design log, he will then decide on when to put the gravel pack, where to place the screen, and then the sanitary seal, he will be watching at this, and then the casing also. all the places that normally should be done. You will be watching at them. So this is how the supervisor can ensure the quality of drilling a borehole. After that, then we'll be having a critical step, which is actually the flushing. Most of the time, when we have the contractor that we are not following, he may do something else, but we should make sure that he does the flushing. Okay, what is then? Why is then the flushing made? The flushing is done to remove all the drilling residues, but also to improve the water inflow in the casing, to clean also the screen and the gravel pad. It helps also to remove the thin sediment to prevent the clogging in the future, or maybe in the near future, I can say. It also helps to check that the water is clear, not for us to have the turbid water in the well. Okay, and it is done by the driller. The flushing is done by the driller. And then why is it done? Is done to develop and to clean the borehole. How is it done? It is done by putting a pump inside sometime, and then in the most cases by the compressor, by air lifting. The air lifting, then they put a high pressure of air inside the borehole, and then the air then will help lifting up some residues and to clean up the screen, as I mentioned it later. In the picture here, you will see that the water is coming up through the effect of actually the air that is going inside. Okay, and it has also to have a duration. The duration of the flushing will depend on the depth and also the geology. What will help us now to determine that we can stop the flushing is that when we have a clear water, and then when we know that the gel is actually stabilized. Okay, you have to bear then in mind that the flushing is different from the borehole testing, which is actually done over hours and then according to some procedures. That is why we have planned to go more in depth tomorrow with our webinar on borehole pumping test at the same time, and then maybe some has resisted already. Arriving here then, we are now going to continue at the third part of our webinar, which is the common mistakes. The common mistakes that we have encountered in terms of drilling the borehole. If I may ask, should someone take maybe 10 seconds to type some common mistake that he has encountered in his project or maybe in drilling the borehole? Feel free to type it. To gain in time, then we are going to continue by saying that the most common mistakes that occur when we are having a borehole are as follow. The poor location choice, like I said it in the beginning. Secondly, we are going to talk about the poor well design. So when the location is poorly chosen, you will realize that the construction also might lead to dry well. And then you will drill it. Later on, it will not produce the water. You will go at the depth that you have designed. You will not find the water. That is why we mentioned that the choosing of the location should be done by accredited geologists when doing the geophysical survey. The poor well design. Then, if the geophysical survey is not well done, we may design it poorly. We will not be able to design the depth and also the diameter. Then it conducts us to the failing of our drilling. The third common mistake that occurs is the improper installation of the casing. This is when actually the supervision is not well done. That is why we emphasize that normally we should be having a supervisor when drilling the borehole, and the supervisor should be recording the information throughout the drilling process. The fourth one that we mention here is the improper well development. As we mention it, we'll be flushing it, but also we have to do the pumping test, both to develop our borehole. If not, we may be failing. And then if not well developed, the borehole will not give us enough water as it should give. Okay. And then later on, the goal that we set at the beginning, saying that we should be providing this amount of water, we may not reach it, and then it goes to the failure and to the loss of money. The poor installation of the pump. Thinking about this one is very crucial, because if we don't install properly or maybe design properly the level where we have to install our pump, it will not function as we said. Let me take an example, like if we install the pump which is above the water level. You see? So you will see that when you pump like 10 or 5 minutes, the water will stop flowing into your tank, and you will think that the water is ended in the well, but really because the pump is already outside. But we still have some water into the well, or into the borehole. The second example here is like when we try to install the pump so much deeper, it will create some turbidity due to the action of the pump, and then the water will be coming up a bit turbid, and people will then say that we are having a turbid water, and the water is not consumable or not pleasant for the community, or need another treatment again. The following mistake that we have seen is the poor well maintenance. When we construct a borehole, normally we should also maintain it. We should try to maintain it. It's like an infrastructure, or maybe like a house that we have built. We need to maintain it properly. Okay. It is advised to do the regular visual inspection. Sometimes we do also the water testing, and also we do the pump maintenance, the pump that we have put inside. All those points contribute to the well maintenance, so it can function normally as we designed it previously. Okay, so we can know that the pump is not functioning well where we can start, or maybe when we realize that maybe the quality of the water is a bit poor, the flow is now limited comparing to the beginning of the operation. And also when we realize that actually our water is not super clear, then we will see that maybe the pump or something else is not functioning in our borehole. The last, not the least, that we have mentioned here, mistake, is actually the contamination. The key issue in well drilling is contamination. So to keep the surface water normally out, or septic tanks or other source of contamination, the well must be built correctly and grouted. That is why we need to supervise correctly our borehole drilling. Then we will talk quickly about the tendering process, which actually incorporates here some different phases when we are doing it. In most of the case, we can separate the geophysics having a separate tender, a borehole drilling and equipment, plus maybe the pumping test together. But in most of the case, these three phases here can be merged. Okay, we just need to clarify them and to bear in mind that there are different techniques by to specify them and to consider for each of the phases. So when merging the contract for all those, we need to be very careful and to be very clear when we are placing the technical specification. Other things that we need to put in mind, because we have mentioned the pump, that normally is also part of the borehole after we have finished the construction. We should not always merge, or maybe we should not at all merge even the motorized pump provision with the drilling contract, because the driller will say, okay, I have drilled it, then let me put this type of pump inside, and then it will be possible that the dimensioning is not correctly done. For this one, in any time that you have the project of having a borehole, please contact your water channel friend, so he can help in terms of designing the accurate pump since the beginning, and he can also help in terms of process. Reaching here, I'm now going to show the last part of the webinar, which are the resources. Talking about the resources, we make available in Logly all the resources that you may need for performing this activity beside the consultation of your technical referent. We have the borehole drilling and design book, which is done by MSF, is a technical sheet for field team. We have also the bill of quantities for borehole drilling, which is also available and accessible to all. We have the third one. This is like a list of drilling equipment, a checklist. When you are having a drilling project, you can just go through and then you check all the equipment and all the list if actually they are accurate. The following resource that we are going to share with you today is actually the construction contract. Because if the contract is not well done or well written, you may have missed some points which are very important in terms of clarifying the contract. The following one is the template of service agreement when doing actually a borehole. In the case that you are trying to have like the geophysical separately, the drilling and the equipment separately, and if you are also willing to do the pumping test separately. Okay, we have mentioned already some few documents at the beginning in the quality ensuring part. We have mentioned the drilling log and also the design log. These are the documents of 1 page each, which are available for our activities. So reaching here, I will now go to summarize the point that we have seen. What we have talked these 45 minutes are actually the considerations. That means actually the community engagement, the need assessment, and the type of borehole in the first part. The second part, we talk about the component that normally, or maybe the steps in drilling a borehole. And at the end, we have talked about the monitoring type, the supervision, how to supervise, and also what are the data to collect. Arriving here, I will thanks everybody and we'll be listening to your questions. Thanks. Your questions are welcome. My colleague Olivier will be around to help in that.
Thank you, Andre. Please, if you'd have, Paul, you can help us with the questions while people are asking their questions. I see there's one question that was already asked from Juba, and I'm seeing some other questions from Theodore. I can start with the first question, which is asking the maximum distance from a borehole to the end users, if I'm not mistaken, right? To answer this question, I would say there is no maximum distance that would say exist to put a borehole from the to separate the borehole and the community or the end users. What you have to take into consideration here is, as Andre was saying, is it will be the proper sizing of a pump that will be able to move the water from within the borehole to the possible location of the end users, whether it's a tap stand, whether it's a water tower, or so. So I don't think in any literature you'd see where they tell you you should install your borehole 10 meters away from the community or 100 meters or one kilometer away from the community. That doesn't exist. But on the other hand, if you have a borehole that has a safe yield of, I would say something stupid, that has a safe yield of 4 cubic meters per hour, and you have a community that is 5 kilometers away, it may be possible to have a pump in the local market or in the market that can be able to give you this safe yield over 5 kilometer distance. That is having taken into consideration another parameter which is very important, the total dynamic head of the system. So it brings into perspective the system design, which should be looked into as a whole component and not just picking one aspect over the other. So to answer that question, the distance can be accounted for in the proper sizing of the pump you are going to install inside your borehole. Then next question, what is that? Can you choose? I think I saw a question about contracts or something like that, no?
There's Theodore's question on
yes,
contract phase 2 drilling popper and phase 3 pumping tests. That's an interesting one for you to Olivier, so you can mention tomorrow's webinar as well.
Mm-hmm. Would it be recommended to hand contract phase 2 and phase 3 to the same contractor given the outcome? Yes, for this one, the drilling proper, the pumping test, this can be handed over to the same contractor. That is a possibility, but we have to ensure that they know what has to be done. The technical specifications for the drilling of the borehole are completely different from the technical specifications from running the running the pump test, which we are going to look into a little bit more tomorrow. But you can give this to them if they show you if they give you proof that they have the required material, to be able to run this this pumping test. Then could it be recommended to hand contract? It's the same question 2 times, right? Okay.
Yes. What we have, I think Watson White Nile got his hand up. If he wants to take off his thing and speak and say hello and give his question, or he can type it in the chat.
I think he can speak.
Hello, hi everyone.
Hello, we can hear you fine. Go ahead, please.
I am Adil from White Nile, WhatsApp manager from White Nile. I have 2 questions. Maybe they are related to each other. It is a specific case in here in White Nile. At the beginning, we were trying to drill boreholes there, but when we did our investigation with the local communities and the local authorities, they tell us that since the 90s, no one tried to drill a borehole. And according to them, that because of the poor quality of the water or the yield of the borehole is very low. Okay, so my first question is, in this case, if you receive information from the community, but still you have doubts because this information is now almost 30 years ago, can you do something about it? For example, pilot borehole or something, or no? The second question, is the type of soil or the geological formation in the ground could be indicator for, let's say, bad water quality or low yield. So here in White Nile, we have black cotton soil. Could black cotton soil be an indicator for both either low yield or bad quality of water? Thank you very much.
Olivier,
thank you, Adil. Yeah, thank you, Adil. For the first question, I think in the beginning, Andre mentioned, yes, it's good to always consider the aspect, the contributions from the local community and stuff. But going for a fact and saying because they said in the 90s or since the 90s, no one has ever drilled because of poor water quality. Yes, that could be possible. But unless we have tested or we have written reports from somewhere that says what they claim, then it may be a little bit challenging to just accept all of what they have all of what they are saying. So it could be a wise decision to always try to do test drilling, which is one of the points which Andre mentioned. It could be a very wise decision to consider doing test drilling. Knowing that we are trying to do this to understand better what is under there, because everything below the ground, without having proper information, proper documentation, may be really difficult to confirm. Just an example on this, not far from you, perhaps in Malakal in South Sudan, there's also this, I would say, seemingly there is also this concern about having, in quotes, salty water with no possibility of drilling in Malakal. But only recently did we notice that in Malakal, where they say it's not possible, there are actually boreholes in Malakal which have been drilled very recently. That's one thing. Then the second is, when they say drilling is not possible, to what extent is it not possible? Because we saw when they were talking about the bore, we saw they were talking about the depths of the boreholes. It could be that the geology, the soil lithology may be 10, 20, 30 meters, 40, 50 meters below ground. Is not suitable. It could be that we have it's on seemingly kind of related to your second question. It could be that the soil material is causing the water in this in this soil formation to be perhaps I would say salty, if they say this way, to have some salt or something like that. You see, but then it means we may not necessarily need to explore this borehole. Perhaps we would have to go down 100 meters deep. Boreholes, as you saw, we can have drinking water boreholes that go up to 300, 400, 500 meters. Yeah, I understand for our context in MSF may be challenging when we start looking into these kinds of figures with respect to borehole depth, but yes, those are possibilities that we can go. So perhaps you're in a location where the proper aquifer which you should exploit is maybe further down and will have to go a little bit deeper down to be able to assess this. Then the second question I'll try to bring it up is if the soil type can tell you if the water quality will be good or not. Am I right? Something like that.
Yes.
Voila, and you gave the example of black cotton soil. I would say it's a little bit tricky to just go by this assessment, because you mentioned in White Nile you have black cotton soil. Up till what extent do you have black cotton soil? I'm not sure you can answer me that question. You may have black cotton soil 5, 10, 6 meters below ground, but maybe
Yes.
at 50 meters you
Yes.
don't have black cotton soil. So if we want to set to base our analysis on the fact that we have black cotton soil means the water quality may be bad or not, that's not very correct. Nonetheless, when you're doing your drillings and then you have the soil lithology characterization, if you find yourselves in some kinds of soils that are kind of salty, you may know that the aquifer you may find in this position may not be a good aquifer, and eventually analysis will help confirm this. You get, so it's something that you have to also assess while doing your drilling. But going superficially and saying, okay, where I'm standing in White Nile, I have black cotton soil, you're not very sure of how deep this soil goes, so you may again want to do more exploratory drilling to be able to understand this further.
Is that okay? And there's other
Okay,
one
thank you.
point. There's other one point.
Thank
can
you
add
very
on-
much. Yes, it is
on
all
black
clear.
cotton
Thank you.
soil. On black cotton soil, it also could be quite difficult to drill it, because the expansion and compaction of the soil, of the black cotton soil when it gets wet, might affect your the trueness, the verticality of your borehole when you do it. Okay. Any other questions by anybody for Andre and Olivier, who did a wonderful presentation on well construction? We have 3 more minutes left. If there's another question, please. All very clear.
I'll highlight one point concerning the geophysics, which was not mentioned, and which is something we have noticed sometimes in our projects, thinking, having in mind that the geophysics is going to be like an exact science. Generally not 100% of geophysics surveys that are carried out should be exact. On the other hand, not 100% of geophysics surveys that are carried out are done properly. So somebody mentioned in the comments here, I don't know whom, the quality of the surveys that are being carried out in the field, which is something that we'll have to look into, that has to be looked into in depth. And why I was bringing this point up is because I've had situations where we have colleagues who say, but we did the geophysics survey and the geophysics survey was not good. So geophysics surveys, it's kind of a science that tries to identify potential water-bearing bodies underground. So there is always a margin of error that can exist with geophysics surveys. So in case you ever encounter this, you should not be discouraged and conclude that the geophysics surveys are not necessarily good. If they are properly done, they will definitely indicate to you where we should be able to drill. Nonetheless, we should always bear in mind there's always a margin of error, and we should be open to these eventualities always. That's why, where possible, it's always good to ask if possible, to do the survey and identify 2, 3, 4 possible drilling locations, so that in case 1 or 2 fail, probably the others could be able to work.
Okay, good. Thank you for that little added thing. There's a Somalia Watson put something in the chat saying, what solutions are available for treating hard water with high levels of calcium and magnesium apart from reverse osmosis?
This is treatment. I think we can cover this. We can register this for perhaps treatment options if need be. But if you would not mind, this does not cover the scope of this. We can discuss later on, but we can register this and talk about treatment options later if you would not mind.
We are looking at doing a treatment webinar maybe in the future, and we'll bring that in. But we'll talk about that later, as Olivier said. But there are resins that you can use for taking that out. But we will do that. And we also have another hand up. Can we have that last hand up, please? Abuja. Flying Watson, please, go ahead.
I have to unmute. 1 second, 1 second. Let me allow your mic. Now you can unmute yourself and go ahead. Please, now you can unmute yourself.
Thank you, Olivier and the team. Thank you, Andre. Thank you, Paul. About geophysics survey, particularly, where I want to direct my question at. Olivier, you made mention that geophysics gives an idea of the water-bearing area, underground, for one to be able to drill a borehole. So I want to understand, does this information gives you the exact depth or the possible depth you should go? Like from the information of the geophysical survey, is it possible to as well determine the depth you could probably go to on your drilling? Basically, that's the question.
Yes, it should be able to give you a rough idea of about how much you go, because what the geophysics does is, I'll take for example the one where we have to send in where we have to measure the resistivity values. It will measure the resistivity values through the different soil layers from the surface going below ground. And if you're 5-10 meters from ground level, it may have a different, I would say some resistivity value, say 10. If you go 20 meters below, it may have something else, and further down. Now, our geophysics friends, in their science, they have characteristics, and they know soils that are, for example, that are what do I say, sandy soils, for example, have a resistivity value of maybe 2. Sandy soils that contain water maybe have a resistivity value of 1. The units I am not very sure of the units and these kinds of things. So they know this. That is why we are asking that. It is always good. We should ask them, because when they go down, when they measure these resistivity values down below ground, they characterize them from the different layers, and then with that they can identify which of them has values or contain value or has values that is closest to what a water-bearing body may have as resistivity.
Okay.
So they should actually be able to give you an idea of what depth we should look at exploring.
Okay.
Lovely. Thank you very much for your question.
Thank you.
And we had one question in the chat again, saying, how can you verify the geophysician knows what he's talking about?
Accreditation, I think that is a challenging question which all of us have to face, but we have to see what is their experience in the country. We have to talk perhaps with people in the country who have worked with. We have to see what they have done, how successful it has been. Look at their qualifications and all of these kinds of things. It's there is no clear-cut answer, but has to be assessed, I think, as Maite is saying, on a case-by-case basis.
Okay, lovely. Thank you very much. And I think that wraps us up for our time. Olivier, can you do a little bit of an advertising for tomorrow's presentation, please?
Yes, tomorrow we would continue. As we said, tomorrow we are going to look a little bit into pump test, what we need, what we should consider, and a little bit as to how to analyze some of the pump test results. So it should be at the same time as this one for today. And ideally, the pumping test is a continuation, an obligatory continuation of the drilling, because especially when we have to consider electrical pumps, we need the result of the pump test to help us to properly size our pumps. So you'd be invited again tomorrow, God willing, so that we can look a little bit into pump test.
Excellent. Thank you very much. And so our last comment is thank you, Andre and Olivia, very much for this very interesting and very clear presentation. Well done, both of you. And hopefully see you all tomorrow. If you have any questions on boreholes and wells, anything like that, feel free to write to us and we can continue these conversations offline. And also when you asked about resins and hardness in water and stuff, please write to us and we can answer that question in more detail. So nothing else is said. Thank you very much, everybody, and have a pleasant evening.
Thank you, Paul, and bye.
Thank you, Andre. Thank you, Olivier.